Did you know that we know more about Mars than we do about our own planet's oceans? It sounds absurd, doesn't it? Yet it's true. While billions are spent exploring space, we often ignore that the majority of Earth is submerged, holding secrets, unknown species, and resources that could change humanity's future. Why are we so far from unlocking this blue universe? The answer is as fascinating as the mysteries it conceals. Imagine diving into a world where every meter descended reveals something entirely new. A place where science, technology, and courage converge to tackle challenges that seem impossible. Why is it that, even today, we've explored space more than the ocean floor? That's precisely what you'll uncover now. Get ready for a journey that will change the way you see the world, and perhaps even yourself. The oceans are like massive sealed books, holding secrets humanity has barely begun to decipher. Covering over 70% of Earth's surface, it's ironic that we know more about Mars than about what lies beneath these waters. Imagine this. Scientists believe there are over 2 million marine species, yet 90% of them remain undescribed. It's like standing before a universal library but only knowing the covers of a few books. Have you ever thought that even when looking at the blue horizon, all we see is just the surface of a vast, unexplored world? This immense mystery not only stirs human curiosity but also feeds our deepest fears. After all, what might be hidden down there? Could it be as astonishing as it is terrifying? From bizarre bioluminescent species to supposed giants dwelling in the depths, the ocean floor continues to be a perfect meeting place for science and imagination. And when we talk about terraforming distant planets like Mars, it's impossible not to think about how we first need to terraform our knowledge of the oceans. But to achieve this, many challenges remain in our way. Shall we discuss them? Exploring the ocean depths is like trying to solve a puzzle with missing pieces. Every meter descended presents challenges straight out of a science fiction movie. Light quickly disappears, and the surrounding world becomes pitch dark. The temperature? Nearly freezing, as if the ocean is conspiring to keep its secrets well hidden. And of course, the pressure. Imagine the weight of a truck on every square centimeter of your body. That's what happens in the deepest regions. It's nature's way of reminding us that, no matter how much science and technology advance, she always has the final word. To overcome these obstacles, humanity has had to reinvent itself. Divers use oxygen tanks, but even they have limits. Submarines, on the other hand, are like mobile fortresses designed to withstand the crushing forces of the deep. The challenge is that even these machines face difficulties. Materials must be ultra-resistant, and the technology used to explore the unknown is constantly being tested. Yet, human persistence knows no bounds, and remarkable feats have already been achieved. Curious to learn about some of them? Let's dive into the next section. The history of underwater exploration is living proof that human persistence can overcome any barrier. Imagine the 1960s, when the bathyscaphe Trieste descended into the Mariana Trench, the deepest point on the planet. There, over 11,000 meters below the surface, Don Walsh and Jacques Picard became the first to witness a world that seemed to belong to another planet. It was like stepping on the moon, but at the ocean's depths, surrounded by a hostile and entirely unknown environment. This feat is still celebrated as one of the greatest achievements in science and technology. Even with such advances, it's intriguing to think that we've explored less of the ocean than we have of space. While interplanetary missions bear the names of agencies like NASA, the ocean depths remain underfunded and often overlooked. Yet this hasn't stopped individuals like filmmaker James Cameron from diving into this endeavor. In 2012, he repeated the historic feat and reached the Mariana Trench's depths, proving that passion for the unknown can move mountains, or, in this case, oceans. But to better understand what's down there, we must start with the basics: mapping the ocean floor. How is that done? Let's uncover it now. Mapping the ocean floor is such a monumental task that it almost sounds like fiction. Did you know we have more detailed maps of Mars than of our own oceans? While satellite images of the red planet have a resolution of 5 meters per pixel, those of the ocean floor reach, at best, 1,000 meters per pixel in some areas. It's like trying to discern the details of a masterpiece through fogged glass. This level of inaccuracy exists because satellites, so efficient in exploring space, cannot penetrate the dense layers of water. For that, we need other technologies. Sonars act as our ears for the ocean floor. Ships emit sound pulses that travel to the seabed and return, creating a 3D map of the submerged terrain. Sounds simple, right? But imagine doing this for the entire ocean. That's why initiatives like Seabed 2030 have emerged, bringing together teams from around the world to create a detailed map of all seas by the end of the decade. Such a map not only helps us locate underwater mountains and deep valleys, but also paves the way for new scientific discoveries. However, with great advances come great responsibilities, including environmental impact. Are we ready to handle them? Let's reflect. Exploration offers us a glimpse into an unknown world, but not without costs. Every technological and scientific advancement aimed at exploring the ocean depths brings significant environmental challenges. For instance, deep-sea mining for rare metals like manganese and cobalt threatens entire ecosystems. Imagine giant machines scraping the ocean floor, destroying habitats of species we don't even know exist. This is a dilemma humanity must face. How far are we willing to go to access the natural resources hidden beneath the ocean floor? Yet, there are great opportunities for a more sustainable future. Technologies used in exploration can be directed toward positive purposes, such as monitoring climate change or predicting natural disasters like tsunamis. Projects like the installation of submarine internet cables, which already connect continents, show that we can use these advancements in a balanced way. But can we explore the ocean floor without causing irreparable harm? It's a question that demands reflection, especially considering the importance of these efforts for humanity's future. Speaking of the future, why do we need to explore the oceans so urgently? Let's find out. Exploring the oceans goes beyond satisfying human curiosity. It's a matter of survival and innovation. Imagine being able to predict tsunamis more accurately or better understand the ocean currents that influence global climate. This information is crucial for preparing populations against natural disasters and even for ensuring food security, as many communities depend on the ocean for survival. Moreover, the oceans are a rich source of emerging technologies, from medicines to solutions for renewable energy. It's science transforming the unknown into concrete possibilities. What's even more fascinating is that each discovery in the ocean depths can reveal clues about Earth's past and even the future of space exploration. If we can handle the extreme pressures and total darkness of the ocean, who knows what else we can achieve? The technology used to explore the oceans could one day enable us to terraform other planets, taking lessons learned from the depths to the stars. But before looking so far ahead, there's still much to discover here. After all, the ocean floor is Earth's final unexplored frontier. What secrets does it still hold? The ocean floor is undoubtedly the last uncharted territory on our planet. In a world where we've already scaled Mount Everest and sent probes to other planets, a vast submerged universe still awaits discovery. Down there, where sunlight never reaches, creatures defy the rules of biology, like the colossal squid and the mysterious anglerfish. These abysses hide secrets that could revolutionize our understanding of life on Earth and even the possibility of life on other planets. Exploring the ocean floor is like opening the final page of a book that has yet to be written. Science and technology have given us tools to overcome seemingly impossible challenges, but we are still merely scratching the surface. What if the ocean isn't just a reservoir of resources or biological mysteries, but also a mirror to better understand humanity's role on this planet? This journey is more than a search for answers. It's an opportunity to connect with something greater. But are we ready for this? After all, mysteries don't end here. They just take new forms. The oceans are both the greatest treasure and the greatest mystery of our planet. With over 70% of Earth's surface covered by water, they hold a vastness of secrets yet to be uncovered. From the unexplored expanse and its unknown species to the natural challenges of the depths and the great achievements of science and technology, every detail reminds us of how little we know about the place we call home. Science has given us tools like sonars and submarines, And projects like Seabed 2030 show that we are only beginning to map this submerged universe. However, exploring the ocean floor isn't just an adventure, it's a necessity. Understanding these depths can help us predict disasters, discover new energy sources, and even unveil secrets about the origin of life. But it also requires responsibility, as environmental impacts could be irreversible. The truth is that the ocean floor is more than an uncharted territory, it's humanity's last great frontier. It's up to us to balance curiosity with preservation, striving for a future where science and technology work for the planet rather than against it. Mapping the ocean floor is such a monumental task that it almost sounds like fiction. Did you know we have more detailed maps of Mars than of our own oceans? While satellite images of the red planet have a resolution of 5 meters per pixel, those of the ocean floor reach, at best, 1,000 meters per pixel in some areas. It's like trying to discern the details of a masterpiece through fogged glass. This level of inaccuracy exists because satellites, so efficient in exploring space, cannot penetrate the dense layers of water. For that, we need other technologies. Sonars act as our ears for the ocean floor. Ships emit sound pulses that travel to the seabed and return, creating a 3D map of the submerged terrain. Sounds simple, right? But imagine doing this for the entire ocean. That's why initiatives like Seabed 2030 have emerged, bringing together teams from around the world to create a detailed map of all seas by the end of the decade. Such a map not only helps us locate underwater mountains and deep valleys but also paves the way for new scientific discoveries. However, with great advances come great responsibilities, including environmental impact. Are we ready to handle them? Let's reflect.